Hi everyone, we're starting on lesson 7.3 today of proving trigonometric identities. Trigonometric identities are formulated from properties and formulas from sine, cosine, tangent, and their inverses. Recall from previous lecture of reciprocal identities. Cosecant theta equals to 1 over sine theta. Secant theta equals 1 over cosine theta. And cotangent theta is 1 over tangent theta. We call the quotient identities. Tangent equals to sine over cosine. And since cotangent is 1 over tangent, cotangent will be equal to cosine over sine. Also recall the Pythagorean identities. Sine squared plus cosine squared equals to 1. 1 plus tangent squared equals secant squared. And 1 plus cotangent squared is equal to cosecant squared. Now let's take a look at example 1 from your learning resources. Prove the following identity. Secant theta times 1 in bracket 1 plus cosine theta equals to 1 plus secant theta. When we approach these identity proving problems, you want to first identify what is on the left side of the equation and what is on the right side of the equation. So on the left side, we have secant theta times in bracket 1 plus cosine theta. And on the right side, we have 1 plus secant theta. Next, what we have to do is make sure the left side equals the right side. And we want to start out with a more complicated looking side. So in this case, the left side seems a little bit more complicated than the right side, so we'll start working with the left side first. We start by expanding secant theta plus secant theta times cosine theta. As mentioned before, secant equals to 1 over cosine, so these two cancels out. So we're left with secant theta plus 1, and that's what we wanted because that's equal to the right side. Since left side equals the right side, therefore the identity is true. Now let's take a look at example 2 from your learning resources. Secant theta equals to tan theta times cosecant theta. We start out by identifying what is on the left side and what is on the right side. So on the left side we have secant theta, on the right side we have tan theta times cosecant theta. The right side seems more complicated, so we'll start by working on the right side first. We mentioned before that tan theta equals to sine over cosine, and cosecant equals to 1 over sine. Now you can easily see that the two sines cancel out, and we're left with 1 over cosine theta, which is the same thing as secant theta, and that's what we wanted on the left side. So since the left side equals to the right side, therefore the identity is true. Now let's take a look at example 3 from your learning resources. We have sine over 1 plus cosine equals to 1 minus cosine over sine. Seems a little complicated at first because both sides of the equation have equal complexity. So step 1, we start out by identifying what's on the left side and what's on the right side. Left side we have sine over 1 plus cosine. On the right side we have 1 minus cosine over sine. It really doesn't matter that much which side we start out on, so we'll just start the left side first. Step 2, replace specific identity to make the left side equal to the right side. What we try to do in this case is we try to form a perfect square. So we times the left side of the equation by 1 minus cosine theta over 1 minus cosine theta, which is basically 1, because we want the bottom to be 1 minus cosine squared. Recall that cosine squared plus sine squared equals to 1, therefore 1 minus cosine squared will equal to sine squared. We divide sine theta from bottom on top, and we'll end up with 1 minus cosine over sine, which is what we wanted because it's the same as the right side. Since left side equals the right side, therefore the identity is true. And that's the end of this lecture. Thank you guys for watching. Remember to check out your activity video as well as your assignment and upload them for your teacher to mark. And I'll see you guys next time.